Everyone say hi to Isaac.
Hi.
Hi, Isaac. Okay, we're recording. We're recording for Isaac since he's left.
Oh.
Yeah. All right, let's grab our 3.1 notes. We're going to be picking up with Objective 5 in our 3.1 notes. We're going to finish pretty quickly. We are ahead of schedule, which means you're going to have plenty of time to get all of your homework done in class today, as well as our small group learning, which this class, did we start that, this group? Okay, the WICS. We started the WICS. So we're going to have time to work on the WICS in class today as well, which is good. Just to recap before we move into this Objective 5, it's important to look back at our Objective 4. And we were looking at our X and Y intercepts. And since I'm recording, I'm going to try to gesture as much digitally as I can. And what did we notice in all of our X-intercepts? I want you to look at our X-intercepts, especially when we looked at the coordinate point version. I'd like you to connect with the neighbor and try to figure out what did all of our X-intercepts have in common. All of the X-intercepts. Discuss this with a neighbor. Tell a neighbor first before you try to share with me or the class. Talk with a neighbor. Whisper to someone else. Whisper to someone else. Looking at the coordinate points of all of our X-intercepts. What do all of our X-intercepts have in common? You will see this especially when we listed our X-intercepts as a coordinate point. Share with a neighbor. Share with a neighbor. All right. Someone want to share something they found or that a neighbor found that all of their X-intercepts had in common? Rachel.
When you do it in the coordinate indices, it's always the first number.
Okay, our X-intercept was always in the first place because our X-intercept is going to be an X value, and in coordinate point format, our X-intercept is always going to be, our X value is always the first point. Okay, we see this again. I'll do this in red here and here. We see this again down here, and we see this again down here. And again down here. What else did all of our X-intercepts have in common? Susanna?
They're all on horizontals.
What do you mean by on horizontals?
Like the line.
Which line?
The one going across.
What is that line called?
X-axis.
They're all on the X-axis. So that, again, that's part of our definition of the X-intercept. It's where they touch the X-axis. So we see this here and here on the X-axis. We see this here on the X-axis, and we see this here, oops, and here on the X-axis. There's one more thing I'm specifically looking for that all of our X-intercepts had in common.
Like
All of them. That is exactly the same for all of our X-intercepts.
They all had 0?
They all had 0. Where?
After the
Where specifically?
In the Y spot.
In the Y spot. So I mentioned this when we introduced, and it's been a little bit for you guys. I mentioned this when we introduced this X-axis, this X-intercept. I said these zeros are going to become important. What we'll notice, and I'll highlight this in blue, is every time we had an X-intercept, the Y value here and here and here and here and here, our Y value was always 0. Which makes sense because the X-intercept is on the x-axis, and what is the y value on the x-axis? How far have we gone up or down? 0. We haven't gone up or down any. We've gone up or down 0, so my y value is 0. This becomes important when we move into our new concept of finding an x or y intercept when we don't have a graph, when we can't just look at the axis when we're given an equation. So how do we find an x-intercept when we're given an equation? Well, what is true for any x-intercept? In other words, when we're trying to find the x-intercept, we're saying, how do we find the x, I'll write this down here, how do we find the x value? Okay, we want to find the x value. X-intercept is the x value where the graph or the function, the equation, touches the x-axis. Well, what is true when the equation touches the x-axis? What is the thing we know is always true at the x-axis, Rachel?
There's always going to be a 0 in one spot.
Yes, so at x-intercepts, y equals 0. We've discovered this. We've seen this as a pattern. All right, so at x-intercepts, y equals 0. So what does my process look like to find an x-intercept when I'm given an equation? First, I set y equal to 0, because that's the thing numerically, algebraically, that I know is always true for every x-intercept. Y always equals 0 for all of them. And then, since what I want to do is find the y value, or sorry, find the x value, the next thing that I'll do is solve for x. I'm going to color code this a little bit more. All right, so because I'm going to walk away from the microphone a second. Because I know at x-intercepts y equals 0, I'm going to start by setting y equal to 0. And then because my goal is to find the x-intercept, which is the x value at the x-axis, I'm going to solve for x to find that x value. And I mention that because for me, when I learned this, I would get confused. X-intercept, x value, y value, which one do I set equal to 0, which one am I solving for, and it can all get kind of confused in my head. So, two things. One, I want you to use your notes. It's the shovel I want you to use to dig the hole. All right? And then number 2, I want us to connect the meaning when I'm trying to find an x-intercept. That means I want the x value, so I'm going to solve for x, because that is the value on the x-axis, and at the x-axis, y is 0. That's why, W-H-Y, that's why I set y equal to 0. Okay? Now, let's scroll back up for a second. This one should be pretty easy now because you guys are pros. What do you think all of our y-intercepts have in common?
0.
What 0?
For the x one.
The x spot. All right, so if we were to look, we can check this. All of our y-intercepts, the x position is 0, 0, 0, y-intercept x equals 0, y-intercept x equals 0. The 0 is really important. So when we come back to objective number 5, we see that at y-intercepts, x equals 0. So to review and connect again, if I'm looking for a y-intercept, what kind of value am I trying to find? An x value or a y value? If I'm looking for a y-intercept, I want to find a what? A y value. So I'm looking for a y-intercept. I want to find a y value. All right, but what is the only thing I know for sure about y-intercepts? That x equals 0. So I'm going to start, number 1, with setting what? X equal to 0, because that's the only thing I start out knowing, is that x equals 0. That's where I start, because that's the thing I know, is that x equals 0. Okay, but then, what was it I wanted to find out?
For what?
The y value. So what will I solve for? Y. So now, I'm going to solve for y. Right. So I hope that helps kind of clarify it rather than just, okay, here's some steps, follow the steps, and if you understand, I don't care, just follow the steps. Because that's how it felt for me when I learned this, and I'm hoping I can connect it a little bit more. So let's do a couple of examples, right? I redid this page. Some of you might have this broken up into 2 columns. If I gave you a new sheet of notes, I redid this for period 2. So they had a little bit more space. We're going to do the best that we can with the space that we have. Now notice in these instructions, are we going to write our intercepts as a number or as an ordered pair? I want everyone to read through, no giving the answer out loud. I want everyone to read through and answer my question to themselves in their mind, so everyone has a chance to do the reading and to come up with an answer on their own. So read those instructions for example 5A. Will we be answering as numbers or as ordered pairs? So we're reading silently. Okay, and then if you think it's a number, you'll say number. If you think it's ordered pair, you'll say pair, like the fruit. All right, ready, set, go.
Number.
Good. All right, and if we get a fraction and it's not proper, will we give our answer as a proper, sorry, as an improper fraction or as a mixed number?
Oh, sorry.
Improper fraction or mixed? Ready, set, go.
Improper.
Improper fraction. No mixed numbers in high school anymore. All right. So default to improper fractions. So let's look at 5A. We're going to answer this one on the left side and kind of save space on the right side for 5B. And this is asking us to find both the x and y intercepts. So we're going to kind of break this up into 2 halves, and I'm going to scroll in to the left side here. So we'll start on the left with the x-intercept. You're welcome to abbreviate x-int as a commonly accepted abbreviation for x-intercept. And when I'm finding an x-intercept, what piece of information do I know? That y equals 0. So I'm going to take my equation and replace y with 0. 10x minus 12 parentheses equals 15. And I replace that y with 0. All right, this was my y. I replaced it with 0. Now, as I go to move to my next step, what is 12, negative 12 times 0? 0. So by substitution property of equality, the equivalent of negative 12 times 0 is 0. And since I'm adding or subtracting that to 10x, I can just drop it. Poof. And I am left with 10x equals 15. And then remember, we're trying to solve for x to find an x value because I'm trying to find an x-intercept. So what issue am I still trying to deal with to solve for x? A constant or a coefficient? Coefficient. Which number is the coefficient? The 10. So I'm going to divide both sides by 10. And x equals a reduced, I do need to fully reduce my fraction. If we have a calculator with a fraction key, if you use that fraction key, it will give you a reduced fraction. If you divide, it's going to give you a decimal, and then you need to hit the SD key to change that to a fraction. If you use the fraction key, it will just give you your answer as a reduced fraction. If your calculator is a TI, you'll need to hit the A, B, C to D, E key or whatever it is to switch between mixed and improper. Our correct answer is what? 3/2. That is an improper, fully simplified fraction. Now, if this were in IXL, what we would enter is 3/2, or the fraction form 3/2. Susanna?
Why couldn't we multiply the y? Why couldn't we do the other one? Multiply 10 by 2?
Because we're finding the x-intercept, so we're trying to find an x value when y equals 0, which means it needs to be the y that we're making equal 0. Now we're going to find the y-intercept. When we find the y-intercept, what is true for a y-intercept? That the x equals 0. There you go. So for the y-intercept, the x equals 0. So we replace the x with 0. So that was a very good question. This time we have 10 times 0. Substitution property of equality is 0. Goes away, and I'm left with my negative 12y equals 15. Do I have a constant or a coefficient?
Coefficient.
And what is my coefficient?
Negative 12.
So I'm going to divide by,
Negative 12.
all right, divide both sides by negative 12. And y equals, now pause, I honestly don't need to deal with, I don't have to deal with the signs in my calculator. If I just remember positive divided by negative is negative. And then you can calculator this or reduce. These are both divisible by 3. And we get what?
A negative 5/4.
5/4. Okay. So this x value is my x-intercept. I would enter 3 fraction 2, or 3/2 for my x-intercept. This y value is my y-intercept, negative 5 fraction 4. If I want to try these as ordered points, let's scroll this up so you can see better. If I wanted to enter these as ordered points, would this go in the first part of the parentheses or the second part of the parentheses? The first, because x always goes in the first part, comma, 0. If I wanted to do this as an ordered point, would it go in the first part or the second part? Second. What would go in the first part?
0.
0. Okay? So we always pair an intercept with a 0.
Okay.
All right? All right. Let's try the other example. Ooh, jumped. If we get this down, the last one's so easy, guys. So easy. All right, I'm going to copy this equation over so that we can kind of work with it over here, which is 13x minus 2y equals negative 26. So I'm just kind of carrying this over from down here so that we can work with it here. X intercept and y intercept. All right, so when we go to find our x-intercept, what will we replace with 0?
What?
Y. Y. No. Okay, y is because the x-intercept is on the x-axis, so we haven't gone up or down, so y is 0. 13x minus 2 equals negative 26. I could really stand to move my line over a little bit. Here we go. So a little more space. All right. Do you guys want to try working this one?
Yeah.
When you get your answer, check it with a neighbor. And if you and the neighbor agree, then we'll check it. With no help. Like, I think just well prepared. Well prepared. So, sometime if you have any availability at lunch tomorrow or Friday, that's down in the crash course on Sunday. Okay. For now, we'll at least get you to get these on Monday. Kind of get caught up with this here. All right, I don't even have to grade that. It's great. That was all perfect. Well, let me put it here and put it on my to grade pile. All right, what did you guys get for the x-intercept?
Negative 2.
Okay. So because it asked us for numbers, our correct answer would be negative 2. If it had asked us for an ordered pair, it would be negative 2 comma 0. Still the same instructions from before. Y-intercept. Did anyone start the y-intercept yet?
Why
No,
start
I
to?
never
Okay, we'll take a minute. We'll take a minute. Let some people work the y-intercept. For Isaac, I'm going to go ahead and work through this. This becomes 0, and I have 13x equals negative 26. I have a coefficient of 13, so I'll divide each side by 13. This cancels. A negative divided by a positive is negative. 26 divided by 13 is 2. Our y-intercept, for our y-intercept, it is on the y-axis where x equals 0. So 13 times 0, oops, minus 2y equals negative 26. 13 times 0 is 0. Negative 2y equals negative 26. I have a coefficient of negative 2, so I'll divide both sides by negative 2. My multiplicative inverse cancels, and y equals negative divided by negative is positive. 26 divided by 2 is 13. Did we all get 13 for our y-intercept? Great job. So how do you guys feel on finding x and y intercepts from a standard form equation?
Yes.
Good. All right, you ready for something even easier?
Yes.
Okay. Did we notice that now? We really have a good handle that we have an x-intercept where y equals 0 and a y-intercept where x equals 0.
Yeah.
Okay? What about when we don't have an equation, we don't have a graph, we have a table of ordered pairs or a list of ordered pairs. This should say intercepts from a table. If you can scratch that out, it's a table. Or ordered pairs. I copy pasted. All right, so where do we have x-intercepts? We have x-intercepts wherever the y value is 0. Where do we have y-intercepts?
When the x value.
There you go. So in example 6a, I'm going to bring this one down here. Number one. What is our x-intercept? We're going to answer these as ordered pairs. Well, how do I know where I have an x-intercept? An x-intercept is where what?
The y equals 0.
Okay, so it's where y equals 0. Where in this table does y equal 0? At the point what?
1, 2, 3.
At the point 3, 0. That's it. Then this one asks, what is the y-intercept? So I'm going to call this number 2. So where do we have y-intercepts?
Where x equals 0.
Where x equals 0. Where on this chart does x equal 0?
0 and negative 12.
At the ordered pair 0, negative 12. That's it. Pretty easy?
Yeah.
Okay. How about with a list of ordered pairs? Okay. Where do we find x-intercepts?
When the y is.
Okay, when y equals 0. So in which of these does y equal 0? At 9, 0. That's it. That's my x-intercept is 9, 0. Because that's where y equals 0. So what is my x-intercept if I just answer it with a number?
9.
9. Okay. How do I find my y-intercept? I have a y-intercept when what?
X equals 0.
When x equals 0. Okay. And for which of these does x equal 0?
0, 8.
So what is my x-intercept? Yeah,
No.
8 or the ordered pair 0, 8. It's that easy. How's that feel? Not too bad?
Good.
All right, we're going to go ahead and take a 5-minute break and be back at 1:40. We'll go 1:45. And when we come back, we are going to work on this assignment.